All right, let's get into synovial joints. So synovial joints have a joint cavity. So what's their connective tissue? Um, they have a lot of different stuff. So let me just go through this anatomy first. Let me draw a picture. I'll go through the anatomy. We'll see if you have any questions after that. I actually want you to watch me draw this instead of just putting up. I'm not going to say anything. I'm just going to draw and fill in some colors. And I want you to start thinking, where have I seen this before? Try and identify what I'm drawing as I'm drawing it. Another masterpiece. Why did I not go to art school? So what do we have? We have this joint cavity, and I know I'm really bad at art. We have this joint cavity. So this is the key characteristic of a synovial joint. It has this space between these bones, and let's look at a few things. So one thing that we notice first is this blue. We've seen this before whenever we talked about our ossification processes. We talk about this hyaline cartilage that's at the end. So now we'll give it a name. This is, instead of just saying hyaline cartilage, because hyaline cartilage is found in a lot of places, now we'll say articulating cartilage or articular cartilage. What is this made of? Hyaline cartilage. Sweet. So that's our cartilage. Next we have this articular capsule. This has an outer and an inner layer. Okay, so the superficial part, or this outer part, is the fibrocapsule. So this dark red that I did over here, this is called, and actually I want to say what these both make up. So we'll say this is the articulating or articular, and then I'll switch colors to show that green. This is called our articular capsule. So a capsule, like a time capsule, you put things in it and then you look at it later. So a capsule is something that is going to hold something. So this capsule, what's within this capsule? This joint cavity, this space. So our articular capsule has two different portions. This exterior, this superficial, this outer, whatever you want to say, that's called our fibrocapsule. Now, if you notice when I was first drawing it, I started on the bone here, and then I went up like that. If you remember your root words, we have two roots, one for surrounding and one for bone. So we have this layer of dense irregular connective tissue that surrounds bones that we talk about. Try and go ahead and give yourself a second to think about what that might be called. Surrounding bone. Those are your two roots. So we talked about that periosteum. So this fibrocapsule is essentially an extension of this periosteum. And if that's the case, then we know it's made of dense, irregular connective tissue. Deep to that, this inner membrane, this inner layer, this is called the synovial membrane. So we finally reached this. When we did membranes before, we did our 4 different types. We did cutaneous, we did mucus, serous, and synovial. There might be one more that I'm missing, but we'll keep that for now. So when we got to synovial membranes, we said, okay, well he said, okay, well we're gonna talk about these when we get to joints. So this is where we're at. So we know a synovial membrane has an epithelial, we know that membranes typically have an epithelial superficial to a deep layer. This is the only exception. This was that connective tissue layer, and this is made of loose or areolar connective tissue. And when I did all those different membranes, I said that synovial membranes secrete synovial fluid. If you also remember, I said serous membranes secrete serous fluid. This is all Unit 2 stuff, so I'm comfortable talking about it. It shouldn't make your brain spin too much. So when we talk about serous membranes, we talked about this fluid being secreted, and the definition of serous fluid is fluid used to lubricate organs to prevent friction during movement. Now that we're looking at synovial fluid, let's switch that word organ for joint. So what is the function of synovial fluid? It's a fluid that lubricates a joint cavity, so in here, lubricates a joint cavity that prevents or reduces friction when movement occurs. So, same exact thing. Synovial membrane secretes synovial fluid. This fluid helps protect against friction during movement. Why are we having movement? Because this is an articulation where two bones are meeting. We're going to get some movement. Okay, so that's our synovial membrane made of this loose areolar connective tissue. We have our synovial fluid. The other thing, we already said, it reduces friction. It's lubricating this joint. It's also keeping these bones from coming in contact and hitting each other. But the last thing that it does, this fluid also contains phagocytes. So we've seen during inflammation, we saw an example of a phagocyte called a macrophage, where it came in and digested the blood clot, ate debris, killed some pathogens. So these phagocytes, these phagocytic cells, I don't know what type of phagocytes they are, phagocytes, whatever you want to call them, but these are going to have an immune function. So macrophages and inflammation have an immune function as a defense mechanism. These phagocytic cells are also going to have an immune function. Okay, and then these last things are ligaments. So ligaments connect bone to bone. Well, here's a bone, and here's a bone. So what's connecting them? These red ligaments. So I did one ligament first, just this line. That's that line there. That is called a capsular ligament. Why? Because it's right near this, and I guess it really technically, if I was going to draw it, this ligament might be more like over here. So it's right next to this articular capsule. All this stuff on top of it, all these lines that I'm drawing right now, these are called extra. Yes, this is an E, not a Z. Extra capsular ligaments. What do ligaments do? They add stability. They regulate movement. That's what these ligaments, so when we talked about those diarthroses at the very beginning, we said highly freely movable joint because we didn't have like cartilage or fibrous connective tissue connecting these two things. But the thing is, these ligaments are limiting movement, right? They're made of fibrous connective tissue, and even though they're not like directly inside this joint cavity, their surrounding limits the amount of movement that it takes place at these joints. Okay, the next one that he mentions are menisci. So if I'm drawing this as my knee joint right here, and I slapped a patella inside there, so there's a patella. Then I have on either side these fibrocartilaginous pads. And we've already talked about these whenever we did bone. We mentioned these. So these are called menisci, a singular meniscus. What's the function of these? They provide protection and cushioning for these load-bearing areas. So what load is coming from this? Your entire body up here. Okay, cool. So this next one that we're going to talk about is a bursa. So a bursa is a sac. It's basically a synovial membrane sac. And it's located between either skin and bone, muscle and bone, or ligaments and bone. So the best one, and he has a really good picture on slide 18, but if you're not looking at this PowerPoint with us, then that's okay. We can still show this head of the humerus here. And we know that we have our clavicle out front and our scapula, our big wing-shaped bone in the back. So what we do here is we'll throw in this bursa, this sac of synovial membrane, like that. And it's going to have synovial fluid. And all that is, it's going to act for cushion and protection, so we don't have this grinding of these clavicles and the scapula against this head of the humerus. So it's just an extra synovial membrane sac that has fluid, acts as cushion and protection. A tendon sheath, so if I have a tendon, let's do a tendon as pink. So this tendon coming down here connecting my muscle to bone, so maybe we're talking about our rotator cuff muscles here, and then those muscles will extend into a tendon. Well, that tendon is also surrounded by a bursa. So when a tendon is surrounded by a bursa, it's called a tendon sheath. So the only other place I've heard of a sheath is like a sword sheath. So you place the sword inside the sheath and then you pull it from its sheath. So this is the same thing. You have a tendon within a sheath. So it's just covering around a tendon. Elongated bursa.